cable companies here. So that's great. MapR's product is an Apache Hadoop distribution, and I'd like to start by asking how many people you can't hear. So I'd like to start by asking how many people here know what Hadoop is, just to get a sense of where we are. Oh, okay, that's awesome. How many have actually used Hadoop in one way or another? Okay, great. So Hadoop is, I'll start by what Hadoop is. Hadoop is, use the mic, okay. I can. Okay, so Hadoop is a distributed system for storing and analyzing large amounts of data, and those can be structured, unstructured, or semi-structured. There's a lot of different use cases for Hadoop. It's very horizontal. MapR's customers, they range from small internet startups with Hadoop running on, MapR running on 10 servers to some very large installations with well over 1,000 servers. So it's really very horizontal. Web companies, financial services, we see telcos, cable companies, credit card companies, a lot of internet companies like ComScore, the Rubicon Project, very large internet companies as well. Our main focus is on making Hadoop open and enterprise grade. The core kind of vision is to make Hadoop easy, dependable, and fast. And it's an open source system with additional extensions that we've made to make it more standard, to support standard interfaces like NFS and ODBC. We include many components in our distribution, and MapR Technologies is already deployed across thousands of companies. So we've been around for about 4 years, spent the first 2 years really just focused on engineering in stealth mode. Now our founders come from companies like Google. One of our co-founders is from Google, where he ran the search infrastructure as well as the Big Table project. Our customers analyze a massive amount of data, hundreds of billions of events every day, and you can see some significant dollar numbers there. Our advantages are around making Hadoop easy, dependable, and fast. And during this demo, I'll demonstrate some of the unique capabilities of MapR. So for this demo, what we have, it's pretty hard to bring. For those who have used Hadoop, Hadoop runs on a cluster of servers, so it's kind of hard to bring a rack of servers here. So what I've done is I've set up a small cluster on Amazon. And also point out that Amazon is a close partner of MapR. They're actually an OEM partner. If you go to Amazon and you use Elastic MapReduce, you can actually use MapR in the back end for that. So we have a very close partnership with Amazon. And that would be an easy way to try out Hadoop for those who aren't using it today. So in this demo, we have one client server, which is actually called M7 Client. M7 is our newest product. And then we have a 3-node cluster. So that would be M7 000 to 002. What I'll do in the demo is I'll start by showing you the user interface for the management console that we have. I'll then show you some of the unique features of MapR, one of them being NFS. NFS is a feature that's unique to MapR and allows us to present a Hadoop cluster as a giant NAS. So you can use your Hadoop environment and mount it just like you would mount any NetApp or EMC appliance and get direct access to the data. It's very easy to load the data into the cluster using that and access it using standard tools. We'll do an HA demo. I'll kill one of the critical processes, and you'll see that in a MapR cluster, all the system daemons recover automatically. There's never any impact to service. So when I said earlier that we've made Hadoop dependable, what we mean is that you can run your data center in a lights out mode where you come in once every 2 weeks and replace the drives that have failed. We'll look at how we create a snapshot, and I'll show you some of the new features in our new M7 edition, which is now in private beta. And that's really about supporting tables as a native construct in Hadoop, so that you now have support for both files and tables, and you can support a variety of types of data. Let's see if I can juggle this. Okay, so we'll start with the MapR user interface. So this is our dashboard. When you log into to the UI for the management console, you'll see a dashboard. You'll see one green box here for every node in the cluster. For a larger cluster, you'll see many more nodes, and the color represents the state of those nodes. So red meaning critical condition, green meaning it's healthy. You can click through on any of these boxes and see what's going on exactly with that node, what the alarms are. You can manage all the services from here, see what disks are being used on that specific node. So going back to the UI, you can see that we have 3 servers in this cluster. I'll click one of them just so you can see this is the 000 server. You can see how much data is currently being used. So very little, currently using very little data, and about 38% of the 38% of the memory here. You can see all the nodes here. You have control. You have different capabilities to filter and slice and dice the data. One of the interesting things about Hadoop is that once you get into these very large clusters, it's really important to provide a dense user interface, because if you have, say, 100 servers or like some of our customers, 1,000 servers, it's very hard to then identify problems if you don't have good visual representations. So that's one of the reasons we've invested a lot in the user interface. What I'll show you now, if we go back to that slide that described the demo, I've actually set up a web server on this what I call the client. The only reason I call it a client is because it's a client to the cluster. So I have a web server here running, and I'm going to hit that web server from my browser, and then show you how that immediately the log files for this web server have been set up to automatically get into this cluster through our NFS interface. So I'm going to put this down here, and we'll see if so right now I'm on the client machine, and the first thing I did here, one of the unique features of the MapR distribution for Hadoop is that it provides a full read-write system underneath. So unlike other Hadoop distributions where the underlying storage layer is a read-only system, with MapR it's fully read-write, just like any traditional storage. And we also expose that through an NFS interface. And what that means is you can now mount the cluster from the client and just access the data like you would any other data. So the first thing I've done is, in the configuration for the Apache web server, we've set up the log directory to be in the MapR cluster. So what I'll do is I'll less the Apache configuration. So you can see here what I've done here is that the default log directory for Apache is /var/log /Apache2, and I've actually changed that to be /mapr/mycluster project access logs. So what this allows me to do now is, once I've done this change, the web server running on the client is now logging the data directly into the cluster. So for those who haven't used Hadoop before, if you're using a different Hadoop, any other Hadoop distribution other than MapR, what you would do is you would actually have the web server log locally and then run some batch process to upload the data once an hour. So not only is that a pretty complex process, it also means that by the time the data gets into the cluster and is ready for analysis, it's pretty old. It's an hour old, right? So that's a limitation with other distributions that we've solved here by allowing you to log directly into the cluster, or to have any application generate its data directly into the cluster. So what I can do now is, you can see here that I just kept the default Apache web server page on this client machine, and I'm gonna hit it directly from my browser here. And why don't I just specify a URL? So this is great Meetup. Okay, so I'm going to hit that a few times, make sure that's in the log file. So I accessed that 3 times. And now if I look at it, I've actually mounted the cluster, remember, from my client machine. And I'm going to, why don't I tail the file? So I'll tail MapR my cluster, and it was in project access logs. And for those familiar with the Apache web server, it puts its log file in a file called access log. So you can see I can access files just using standard utilities like tail and less and grep or anything like that. If I look here, I should be able to see that I've accessed this page. So you can see that I've accessed it actually 3 times. And what's interesting is that this log file is now in the Hadoop cluster. I can now run a MapReduce job or an SQL query on that data directly in my Hadoop environment, and that data is already there. So I'm actually processing data that's no more than 5 seconds or 30 seconds old. So why don't I go to the I'll go to the Hadoop cluster now. So now I'm on the 000 node. So this is one of the nodes inside the cluster. I'm going to run a simple MapReduce job. This is one of the samples actually that comes with Hadoop. All it does is counts the number of occurrences of each word in a file. So what I'll do is, so this is just how you run a job in Hadoop. So this is the examples jar. In that, there's various examples. I'm going to run the word count example, and I'll provide as input. I can just provide the file that was just created. So my clusters project access logs, and then the input file was access log. And I have to provide an output directory, which is where the job's output will be. So what I'll do is I'll just create some directory. We'll call it my count. See how that works. I probably don't have I'm using the wrong user. Okay, let's try that again. Spell something. Okay, I just had a typo in there. So I'm running this word count job, and the output's going to be in the MapR my count directory. 2 minutes. Okay. So you can see that that's a MapReduce job. That's basically a process that ran in a distributed way across the cluster, and now the output's available in my directory. So I can cat that file MapR. And you can see this is a great Meetup showed up 3 times. You can see that I practiced this at home. So, okay, one last thing I'll show. Actually, time goes by faster than I anticipated. Is something called snapshots. So we're able to create snapshots the way you would do in any file, any network attached storage, for example. If you think about any other enterprise class infrastructure system, whether it's storage or databases, things like NetApp, EMC, Oracle, Teradata, they all have the ability to go back in time. So if somebody accidentally deleted a file or an application corrupted data, you can then go back in time. So that's another unique feature that MapR provides and allows you to go back in time. So if I create a snapshot now of that user MapR directory, I'm going to select that and just create a snapshot of that data, and we'll call it my snapshot. What I'll do now is I'll go and delete that file that we had just created, the output of that run. So I shall delete the entire directory to show that works too. So you can see I've deleted that entire directory. It's no longer there. But because I have this snapshot cape, and that was simulating a user mistake, some user in the company making a mistake, accidentally deleting files, I can now show you that file is actually still there. So if I go to my cluster, user, MapR, there's a hidden directory called .snapshot. You're actually not going to see it in the directory, but if you access that directory, you'll see that snapshot is actually there. And if I cd into that, I can actually I'll basically see the data as it was at that point in time. So in this case, the directory was called my count, and I'm just going to access that, and you can see that file is still there. So So that's what snapshots provide, is that ability to go back in time and see the data as it was. And obviously when you're using a cluster, you can just define your snapshot policy. So we have schedules that let you define, for example, how frequently you create a snapshot of every subset of your data, like an hourly snapshot or a daily snapshot or a weekly snapshot. So that's kind of a quick overview of MapR. You can obviously go to the MapR website. That's just mapr.com, and there's a free edition called M3. There's also a trial version of the M5, which is the enterprise product, which has all the functionality for 30 days. So with that, happy to take any questions. I think we have a few minutes for questions. Right?
Yeah.
That works. Okay. Any questions? Yeah.
You mentioned Amazon being a partner. Have they built AMIs ready to go with MapR ready to go on it? Like,
it's actually a lot more than that. So I'll actually have it open here. If you go to Amazon, has a service called Elastic MapReduce. So if I go to Elastic MapReduce and I create a new, it's called a job flow. Basically, there's a drop down here that lets you choose between the Amazon distribution, which is what they actually had before MapR even existed. And then, their customers were asking for all these enterprise-grade capabilities, and so they've actually partnered with us, and they now offer 2 additional versions, which are essentially the MapR editions. So that's a good kind of proof point for us. I think the only other companies or 2 of the other companies that Amazon has partnered with at this level, where it shows up in the user interface, are companies like Oracle and Red Hat. And then Google is another cloud partner of MapR. They've also selected the MapR distribution as their Hadoop platform. Okay, thank you.